Hi everyone. Hello. Can you hear me? If you want, you can use the chat mode and just tell me if you are able to hear my voice and see my screen. Can you hear me? Yeah? Okay. Thank you. Thank you everyone. So it's fine. Okay, I think we can start now. So I just want to introduce my colleague DJ and me directly, and then we will start the webinar based on the Gmag and Psim coupling chain. Okay. So DJ, if you want, you can start to introduce yourself.
Hello, hello, everybody. So my name is DJ Zefrak. So I am in charge of JMAG software. So with JMAG, I make support. I make project for our customer. So today we will try to show you what we can do with JMAG Designer. Yeah, and feel free to ask any question on that. Thank you.
Thank you, Didier. Okay, so on my side, I'm Adrian Michel. I'm the Psim support guy at PowerSys company. So I every day deal with my customers when they have any trouble with Psim. So I am just technical guys as DJ is doing for Gmag. I am doing the same thing for Psim simulation software. So I hope most of you knows Psim. And just to sum up, DJ and I, we are working at PowerSys company, and we are the distributor of Gmag software and Psim for Europe, but also some other countries in the world, but mainly for Europe side. So I guess most of you are Gmag and Psim customers, so you know PowerSys, you know us. And the goal of this webinar today, as DJ mentioned, is to present you the coupling between Gmag and Psim software. So this is the best, I guess, at PowerSys side, the best tool chain for MBD, for model-based design development of electrical motors. So we will show you through this webinar how to drive a motor properly and efficiently in a speed, in a fast and speed way. Okay, in order by using Psim and Gmag all together. So we will show you how to go from the Gmag to the Psim side by using all the different links between each software. And at the end, I will present you a good tool from Psim, which is a new advanced tool. This is a motor control design suite. So I'm sorry, but yeah, just to start with the agenda. I will present you very quickly Psim, and then we will go through Gmag side. Then I will show you the different links between Gmag, okay, and Psim, because there is not only one way. You can do by your own way if you want to make the co-simulation, for example. And at the end, I will present you the motor control design suite tool from Psim, which is a advanced and fast tool if you want to drive with an accurate way your electrical motor. So you can couple the motor control design suite from Psim with Gmag RT, for example, and then you can drive your motor. And at the end, we will show you a case study that we have done, DJ and I, by using all the link between Psim and Gmag, and also by using the motor control design suite. This is the goal of this webinar. Okay, quick presentation of Psim. So for people who don't know really what is Psim, so Psim is by excellence the ultimate simulation environment for power electronics, motor drive, and energy conversion applications. So in Psim, you can design any power converters. For example, if your goal is to just to work in SMPS, okay, switch mode power supply, or also you can drive any motors into Psim. So we have a full library for power stage, semiconductors component, control components. Also, you can also work in analog domain, in digital domain, if you are working with microcontroller. But at the end, you can link a motor, and you can make a simulation between Psim and this motor. And it could be by using Gmag, but also it could be by using the processor in the loop capability. So you can plug physically your motor, okay, with your USB cable and so on. Okay, you can, and at the end you can drive your motor by using Code Composer Studio. You can also use the motor control design suite and some tools from Texas Instruments like the InstaSpin for motor parameters identification. And you can make a kind of processor in a loop simulation or hardware also in a loop simulation. It's possible to do that. So Psim provide expert circuits and system level design and simulation capabilities in order to empower engineers in the power electronic design industry. So this is the main goal of Psim. And also at the end, you can also use Psim with other software like LTSpice, like MATLAB Simulink, and also Gmag, Gmag RT, and Gmag Express. So you can use Psim with all this kind of environment. And to show in a deeper way the environment of Psim, you can see this screen, this slide. So in Psim, you have the capability to generate automatically code if you want for C code purpose. You can also calculate the losses of your semiconductors component, for example. You can use Psim with motor drive application, renewable energy, with PV, supercapacitor, battery model. You can also use extra software, as I told you, with Gmag and Simulink. You can use some microcontroller from Texas Instrument and make a kind of processor in a loop simulation. Your power stage is in Psim, your control stage is in your microcontroller, and you can plug your motor physically. And we have also extra software which allow you to design the control stage for you, like smart control and relay engineering software. But we have also a good add-on, a good module for Psim, which are the HEV for hybrid electric vehicle, the motor drive with the motor control design suite, the LLC for LLC converter design, and the EMI design suite for simulation and control, and I mean simulate and knows the EMI compliance with your circuit. So basically, you can do all this stuff with Psim, and you can also use Spice, also link, and also Decim, which is the fastest solver which has been included into the Psim solver. So if you are interested to test Psim, feel free to contact us and we will help you, basically. So this is just a basic presentation of Psim. Now we will go through Gmag and then we will go through the main goal of this webinar. So Didier, you can share your screen now. Didier?
Can you hear me? So can you make me presentator? So make click on my name and then put me host, something like that. Because I cannot share.
Yeah, I will do. You are the guy.
Okay, now I'm sure.
Yep.
Okay, so thank you to show the Psim and environment. So now let's focus on the JMAG environment. So not that JMAG, it is a 2D, 3D or 3D final element software dedicated to the simulation and the development of any electromechanical system. Okay. So if we look the different step to design the motor, so we start from concept design to the validation or testing. So at each step of the design, Gmag will provide you a specific tool. So for example, for the basic design in the concept design, Gmag provide you Gmag Express. So Gmag Express, it is a 2D tool that allow you to get in 1 second all the basic characteristics of your motors. So with JMAG Express, you will, for example, you can create the geometry based on the rate power of your motors, and you will be able to also define some basic characteristics of the motor, then get the geometry and get the result. So you also have the free online version of Gmag Express, which is free, so you don't need to have a license. So you just need to create a free account, then you will be able to access Gmag Express, where you will discover different motor template. Then when you are finished to design the reference shape of your motor using Express, now you can switch on the design step, where you will use JMAG Designer. So JMAG Designer is the main tool of JMAG, where you will make where you will define a particular parameter. So for example, you will control the mesh quality, or you will add some specific condition in order to get the result with more accuracy. With JMAG Designer, you will also able to exchange or make a customization with other software, like safety software, mechanical software, or also CQ software. And for the validation or testing, you can use JMAG RT to convert the 2D or 3D finite element model into a 1D component, which will contain all the basic, all the characteristics of your motor that you have, that is extract from designer. Then with the 1D component, you will be able to import that into the SQL software or into the test bench in order to run the simulation. So if we focus on the JMAG designer, you will see that we can do many uh, analysis. Yeah, for example, let's take this example of motor test bench. You can see that the main analysis that we can do with JMI is the multi-field analysis, where we will check, for example, the distribution of the multiflux inside the motor shape. We will be able to get the loss of the winding wire. We can also get the distribution of the iron loss. We can check the effect of the cemented magnet. Yeah, we can make thermal analysis in order to check the distribution of the temperature inside the motors, also inside the temperature of the magnet. We can make a mechanical analysis in order to check the effect or the deformation of the rotor due to the centrifugal force. We can also make the NVH calculation in order to check to measure the noise into the state of, for example, due to the electromagnetic force that you have from the stator T. Uh, we can also calculate the loss into the component that we have around the motor, like the tank. The advantage of JMAG is that we can also extract some maps. For example, we can get the efficiency map. We can also extract the engines LGLQ map. We can extract the mechanical power map. So we have a lot of map that we can extract from JMAG. And the advantage that we want to show you during this webinar is that with JMAG, we are also able to make a co-simulation between JMAG model with a circuit software like Psim or Simulink. So today we will show how we can do that with Psim. Okay, so any different application can be simulated with into JMAG. So we have a motor to the transformer. All this kind of application can be used in the JMAG designer or JMAG RT model. Okay, so then now I can give back the control to Adrien for which will show you the link between JMAG and Psim.
Thank you, DJ. I guess you have to give me the right to share my screen again.
Correct? Is it okay from your side?
Yes, it's perfect. Thank you, DJ.
Thank you. Yeah.
Okay, let's go now to the main things of this webinar. First, the use of Gmag link into Psim. So how to use the Gmag capability with Psim? Because I guess most of you are maybe engineers in design of electromechanics stuff, or maybe you design your own electric motor and you, I guess, needs to design also, maybe another team needs to design the power electronics behind before the electric motor. So I think this link could be also useful in order to use a software which can drive your motor correctly. So first, we have two different links, okay, into between Psim and Gmag. Okay, so as you may know, the motor parameters from Gmag will be exported and used inside the Psim machine models. Okay, it could be the first link, the ideal link with linear motor into Psim. You can extract basic component from Gmag like RS, LD, LQ, the back EMF, and some other parameters. You can extract them. You can use a linear motor from Psim and you can put the parameters inside it. And then you can make your simulation. But the two main links that we use between for Gmag and Psim are the Mag coupler and Mag coupler RT. So first, the Mag coupler is the direct link between Psim and Gmag Designer if you want to make a real co-simulation. And then you can exchange data between both software in real time. Or you can use Mag coupler RT, which is the module, the link between Psim and Gmag RT. And this is an indirect co-simulation because, as you may know, you from Gmag Designer, you will use Gmag RT, you will export the RTT table, you will extract the RTT table from Gmag RT, and then you will import it into Psim. So it is the other way, which is the fastest way also, but it is indirect. Okay, the data are not exchanged in real time because Psim will use the RTT table from Gmag RT in order to make the simulation. Okay, and we have also the new link, which is Gmag Express. Also, you can use Gmag Express, maybe you know it, and you can directly extract the RT model from Gmag Express, and you can import it again into Psim. This is just another way. So just think about the direct link with Mag coupler and the indirect link with Gmag RT, with Mag coupler RT. So why you need to use Psim and Gmag? So I think your main trouble is to design the electric motor. For that, you have to do it into Gmag as you used to do. Okay, you will design your own electric motor by using the specification of your customers, for example, or from your management. Then you will export the model, okay, the main parameters, or you will export directly the model into Psim, and then you will be able to make the simulation. This is your main focus, is to use Gmag. But as you may know, you need to drive your motor, and for that you need to use something. You need to use a tool. So Psim could do that for you because we have some templates. We have some design suites. We have a tool named the design suite, which help you directly to make the closed control loop of your motor. It could be a torque speed, a torque loop, a speed loop. It could be also in current loop. So we have some design which has been done directly from the Psim developer, and you can use this kind of slide and adapt it very quickly to your motor. So you can just close the loop. This is the main thing you have to learn. But also you can also calculate the losses of your inverter. You can also calculate the losses of your drive of your motor and also um, of your motor. And at the end, you can also use scripting capability if you want to automate your system. If you want to make some worst case scenario, it's possible. And you can also obtain the efficiency of your overall system if you want by using this kind of scripting and our design suites tool. So just the link. And just to show you how it is look like. So you have the Psim side, okay? And here you have the motor. This motor is extracted from Gmag. So this is just a screenshot of Gmag, and it is a PMSM motor. So the power and the control will be done in Psim. The motor will come from Gmag, and you can use the co-simulation link because you are using the Gmag Designer tool. Here, this is just the process in order to extract in order to first build your motor into Gmag and then extract the main parameters and use it with Psim. So first, you have to create your Gmag magnetic model. You will simulate it as you used to do in order to get basic information, current, torque, for example, voltage, and so on. Then you have to add some condition in order to make it work with Psim. You have to use the external link 1 or link 2. It depends if you want to use MAC coupler or MAC coupler DLL with Psim. You have to generate the mesh, basically, and you have to export the mesh in order to get the GCF file and the XML file. And in fact, this GCF and XML file are the main circuits to use with Psim. So in Psim, you will just open the PMSM motor and you will be able to load the GCF and XML file directly. And then you will be able to simulate and observe the result. This is a basic process. Just extract these two files, GCF, XML, and import them into Psim and run. So then, as it is by using Gmag Designer, it is a co-simulation. So as you can see, we have the screen with Psim, we have this screen, this picture with Gmag, and then you will, during the simulation, as it is a co-simulation, it will directly import some parameters. Okay, so it will be exported and imported. So for example, from Psim, you will be able to export these main parameters into Gmag. So you can check the voltage, current, you can also check the rotation, translation of motion, and so on. And then Gmag will perform its calculation and will send back to Psim some other information that Psim needs. Okay, so you can see the output parameters that Gmag will send back to Psim, and then it will exchange in real time this data.
just to add something, note that so this is the first confirmation method using the finite element model. So into Gmag, you will build the finite element model. Then Psim will run in background Gmag designer to solve the finite element problem. And then Gmag from Psim, you can control the simulation step into Gmag. You can set voltage or current. You can define the switch, the position of the switch. You can control the rotation, also the motion. Then Gmag will run the finite element calculation in background, and it will send back the result. So the force, the electromotive force, the torque, also the voltage or current, and also the position of the rotor. So it will send that into a Psim, and then Gmag and Psim will make a loop. We exchange by making a loop. So this is the first confirmation way using finite element data.
Yeah,
Okay, thank you.
thanks, DJ. So, okay, the other way, so the second way is to use the link with Gmag RT. Okay, so Gmag RT will also deliver a very accurate model, okay, of your electric motor, and you will be, of course, able to use it into Psim by using this kind of lookup table, in fact. So here, the process is very easy. So first you have to use Gmag Designer in order to create your motor, okay? And then you have to use Gmag RT in order to generate the RTT file from your motor. At the end, you can directly load this RTT file into Psim by using the MacCoupler RT module, and then you can simulate. So it means you can use the same circuit, the same power stage, the same control stage, but you can use, if you want, the co-simulation, or you can use, you can replace the real PMSM from co-simulation to the real one, but by using Gmag RT.
Yeah, just to add something here.
Yeah.
Yeah. Okay. So you can see that on both method, we need to create the finite element model. So into Gmag designer. Then we will use Gmag RT to convert the 2D or 3D finite element model into a 1D component that we can import into a sequence of write like a Psim. So this 1D component, it is we call RT table file that we can use into the Psim software. Yeah. So this is the second confirmation way.
So thank you, Didier. So the last one is very close to the second one, is to use the Gmag Express link. As you may know, you can go on the Gmag Express website. You can create your own account and you can design your own electric motor by using also Gmag Express. And at the end, you can export, you can generate the RTT table, the 1D lookup table, and at the end, you can directly also load it directly into Psim. Okay, so this is just the sum up of the different links. You can use the first way, which is a direct co-simulation with Gmag Designer. Okay, you have the second way to use Gmag RT in order to extract the RTT file and load it into Psim. And the last way is just to use the Gmag Express and extract again an RTT file. This is just the different links between Psim and Gmag. Okay, now the next step is, if you know how to drive your motor, it's perfect. You can do it to Psim. You can design your own power stage, your own control stage. It depends if you want to implement a field-oriented control, a field weakening control, and so on. There is some kind of algorithm, some kind of methodology if you want to drive your motor, and if you know how to do that, if your control design team knows to do that, you can directly use Psim, okay? And you as an Gmag engineer, you can directly use your own motor and you can, plug, merge everything, and you can adapt your control to your motor. This is the normal way, I guess, that some people used to do. But we have here a tool in Psim which help you to design for you automatically the control loop for driving your motor. And the tool is the MCDS, the Motor Control Design Suite. Okay, so you can use the Motor Control Design Suite to drive any motors, but now you can use also Gmag, the Gmag RT link, in order to drive your motor. And I will show you how to work, and it will design for you everything. This is the easiest workflow for any engineers, because even if you don't have 10 or maybe 20 years of experience in control strategy, you can use this kind of tool, and it will help you so much to get a quick overview of control parameters you need to use for prototyping, for example. So motor control, what you need, in fact. So the main thing is, after a motor design, you want to evaluate the performance of this motor. You want to check the torque, the power, and the speed. Okay, and how to calculate that. So if your motor is already designed, okay, you will ask you will need to answer to a lot of questions, like how to obtain my maximum torque, how to obtain my maximum speed, and how to obtain the highest power with the highest efficiency by using some motor control algorithm. So to do that, okay, you will need to use your own knowledge, or you can use this motor control design suite, because your objective is to maximize the use of the motor. Okay, you need to get always speed, even in you need to get always torque and power. I mean, even in high speed region. Okay, so you need to know the limit of your motor, and you need to calculate the best motor control method possible. And for that, again, you can use Psim and the motor control design suite. And of course, you can still consider the nonlinear effect and high-speed operation during the simulation. This is the main strategy of Psim. So here, this is the motor control design suite uh, screenshot. Okay, we have a panel, okay, a left panel with the main parameters to change, and here you have everything. You have the bus, the supply, okay, so voltage supply. You have the inverter. You have your motor. So this motor could come from Gmag, and you have your control stage. And this control stage use advanced methodology in order to pilot your motor. Okay, because you can model. Okay, you can your motor could be uh, real. It is not nonlinear in this case, so it will represent the nonlinear effects. Okay, and nonlinear behavior. Then the nonlinear motor control, okay, is adapt to the control of the nonlinear motor designed by Gmag. So I think it's good, because if you have a perfect control stage and nonlinear motor, it is not very accurate at the end. So you can represent the nonlinear effect in both sides. Again, you can achieve the best drive performance possible using different algorithms like MPTA, field weakening control, MPTV, which is new in Psim, and MPTF, maximum torque per flux. And also, it enables Gmag design motor to operate as at a very high speed. This is the main goal of this new control, like MPTV and MPTF. You can still get torque and power in high speed. Okay. And also you can still use our Psim thermal capability if you want to calculate the losses of your motor and of your inverter, or both you can calculate. So here, this is just a new uh, a new capability in Psim. As you can see, we have a button, which is the speed torque curve. So this button gives a quick view in 1 second um, of, the view, okay, of your power and torque, depending on the speed of your motor. So by using, in fact, these parameters of voltage, current, motor parameters, and so on, it will calculate for you the power and the torque. Then you can have a quick overview of your specification and the result at the end of your simulation. It's just a quick overview. So if you are not happy with that, again, you can still change these parameters and you will see that this curve will change, basically. But here, the main things to do is using this kind of motor control design suite in order to pilot your motor. So you don't need to modify all this stuff because everything has been designed automatically. You can do it, of course, but it's not needed. The only thing you need to do is just to modify the value of your input voltage, of your maximum current, switching frequency of your IGBTs, if you use IGBTs, of course, the basic parameters of your motor and the motor controller in order to design the speed loop and torque loop, for example, and so on. So you have the sampling frequency, crossover frequency of your simulation of your circuit. So you just need to modify these parameters on the left side here at the bottom. And here you can just modify the input speed that you want to reach, depending of your specification of your motor. So it could be 6,000 RPM, but if you want, you can also turn at 10,000 if you want. And your motor at the end need to reach in steady state this 10,000 RPM. This is the main goal of this motor control design suite. And here, this is just a slide showing what the MPTV can do for you. For example, you can, as you can see in the blue curve, you can still extract torque here and power here. Because in general, when you use basic algorithm, okay, like MPTA and free weakening, at the high speed, you have no power, no torque. But here, with the new algorithm, MPTV and MPTF, you can still extract a lot of powers, even in high-speed region. And you can see that your motor is still efficient. You can also use our efficiency capability. So in Psim, we have some tools, some templates, again, which help to make a script, and at the end of the script, you can extract uh, some uh, some some picture. Okay, and this picture, for example, will help people to design and to know, in fact, the efficiency of the inverter, of the motor, and of all your system in general, basically. And you can directly check the efficiency here by playing with the motor, the speed, and by the torque. So you can know where is the maximum efficiency at which speed, at which torque, basically. So Psim can do also uh, that for you. And if you are not happy with that, again, you can modify your control strategy and check if the efficiency is better at the same speed, same torque, for example. So Psim can do extract parameters for you and load directly this kind of picture, and you will be able to see them. And the next step is not only to use linear motor, but also you can use Gmag motor if you want. You can use the motor control design suite with Gmag designer and with Gmag RT if you want. So it means if you first want to make the control stage of a linear motor, it's perfect because it will be your starting point. You need to know the basic motor parameters that you need to use into Psim. And at the end, once you have designed the control loop, I mean the drive of your motor for your linear motor, you can replace your linear motor by your real motor. And your real motor could come from Gmag RT, or it could come from directly from Gmag designer if you want to prefer to make a co-simulation. This is the main goal of this motor control design suite, in fact, to do everything for you in a couple of minutes, couple of hours, if you prefer. And at the end, you can sweep and you can directly use Gmag motor with your motor control design suite capability. And if you prefer, you can also use Gmag Express online if you also want to design your motor directly from JMAG Express and export the RTT file, and then you will be able to export and to load the RTT file into Psim. And just as a reminder, now you can use all the Gmag RT motor types are available and compatible with Psim. So it could be a PMSM, it could be any solenoid, linear synchronous motor, step motor, SRM motor, wheel feed synchronous motor, induction motor, and to sum up, it could be any generic model. So any RT motor could be imported into Psim, basically. And it could be from Gmag RT itself, or it could be also from Gmag Express. So here it's just a basic simulation, okay, and just result of your motor control design suite with Gmag RT. And as you can see here, you can see the speed. So you have a reference of maybe 6,000 RPM. So as you can see, your motor is increasing, the speed is increasing in order to reach your 6,000 RPM. You can see the current, which are in steady state here, very stable. You can see the torque and LDLQ, and you can also check the losses. It could be copper losses, eddy losses, and hysteresis losses, okay, regarding your motor, but also it could be the losses of your inverter if you are interested in, if you want to check the condition losses and switching losses of your IGBTs, okay? And you have the advanced control in all the green stage. You have the PMSM from Gmag RT here, and you have your specification of your motor and of your circuit in general. Voltage, current, switching frequency, and motor control parameters directly. And here, this is just the workflow that you can use in order to use first Gmag. If you prefer, you can use Gmag to design your motor, or Gmag RT, or Gmag Express. Then you can use our motor control design suite. You have to load your motor from Gmag into Psim, make the control loop, check the parameters, and the control loop will be done automatically. And at the end, just simulate. And after that, you can check directly in Psim the result of your simulation. And it could be a co-simulation, of course, if you use a direct link. So what are the benefits for you guys, for the Gmag people? First, it provides Gmag torque control templates. Okay, so Psim can do for that. It provides any templates for you, and also it could provide a torque and speed template, and you can drive your system very quickly. It can generate for you the efficiency map for the whole drive system. It can also provide for you the LDLQ table if you want to obtain the best LDLQ value for your control strategy. And also it can help you to design to make the control loop for any Gmag tools. For example, Gmag Express, Gmag RT, and Gmag Designer. And at the end, it will evaluate and simulate your final real simulation for your electric motor. And then you can do your prototype. So Now I think the thing you are waiting is a case study. Is okay. From now it was theory, but now we are going to show what we have done with DJ in order to make for you some demonstration. First, we have taken one motor, okay, from Gmag designer, and we have designed it. So Didier has designed this motor into Gmag designer. So you can see here directly the specification of your motor. So the maximum speed is 2000, maximum voltage is 200 volt, maximum current peak is 1 ampere. You can see the different type. It is a star connection type, number of pole 4, free phase, and so on. Okay, you can see the basic specification of your motor. The objective is, okay, we want to drive this motor. First, we want to drive it with linear motor in Psim because this is our starting point. I guess it is always good to make your control loop not with the real motor at the beginning, but with a linear motor in order to just see what is your speed at the end, what is the torque and so on, check the voltage and current, and see if your control is working well with a linear one. Once it is done, once your control has been done for the linear motor, you can go to the non-linear motor, and then Gmag will come at this stage. So the case study has been to use, okay, first my PMSM that DJ has designed, okay, this one, but in Psim, but by using a linear circuit with basic parameters that we have extracted from Gmag Designer. As I told you, I think it is there, but this is these basic parameters that the PMSM needs to use in Psim in order to simulate. You need to know the RS, okay, the stator winding resistance, the value of LD, of LQ, the back EMF, the number of pole, the rotor inertia, the shaft time constant, okay, and also you can set up, fill in the initial rotor angle if you have an angle with the rotor at the beginning of your simulation. This is the basic parameters. Once you have done this when you have filled in these basic parameters, we have designed this control strategy. Okay, so first we have here in the left side the DC bus. You have the three-phase inverter, okay, in order to pilot your motor, and we have done this control strategy, okay, by using basic things. In fact, okay, so we will in fact measure the current, okay. We will then feed the different this ABC to DQ transformation block, okay, with the current, and we will have a current reference and speed reference. And then by using some PI compensator, okay, we will make the control by using this PI mainly, okay, but also we will use again this GQ to ABC transformation in order to generate the PWM here, and in order to get the modulating signal and we will compare it with the carrier waveform. Okay, and then we will have some PWM signals which will directly turn on or turn off the IGBTs there. So this is basic things, okay? And here we will get the speed and we will integrate the speed in order to get the theta value, okay? The displacement of your motor. So we have done that, okay, with with linear behavior. It is these parameters come from Gmag, but this motor will have a more ideal behavior. Okay, and now I will show you the result into Psim. So I will put in a bigger screen. you can see exactly what I have shown you, okay, with the Psim, okay, the PMSM with linear behavior. And once we have simulate, we have obtained this. Just I have unzoom. You can see the speed, okay, because my reference speed is 2000, as I have told you. So I succeed to reach my 2000 RPM. You can see the torque here. This is the same torque as we have obtained from Gmag, okay. And here you can see the free phase current, which are quite sinusoidal, okay. But this is a linear behavior. But my control is working well. Then the next things has been, I go back with my slide, is to directly use the co-simulation. So as I told you, I keep the same circuit, but I replace with my Gmag designer motor. Okay, for that, this is easy. As I told you, you need to export the XML and the GCF file that you have created from Gmag designer. Then, once you have the GCF and XML file, you can directly use a direct Mag coupler block. This is a direct link between Psim and Gmag, and you can load directly. You can fill in this file, you can load them, and then you can simulate. And if I come back with Psim, you can see here the same circuit as I told you, with my coupler here with the GCF and XML. We have added some extra blocks in order to calculate the speed and the theta displacement again. We have just added some extra sources in order to feed this motor with voltage, and in output we have the current, okay? And at the end, when we have simulated, we have obtained this result. Again, we have 2000 RPM, you can see the torque and the current, okay? So the main part, the main difficult part is just to design correctly the motor into Gmag, okay? But at the end, if your control is done with Psim, the behavior will be quite close because your control design has already been designed. And then the next step has been, okay, for Psim linear model, it works, with Gmag it works, but we want to also use Gmag RT, okay? Because there is some advantages to use Gmag RT. So we have again used the same circuits, okay? But now we have replaced my Gmag designer motor by the Gmag RT motor, by the lookup table data. And these data are directly stored into the XML file, okay, and the RTT one. Once we have done that, okay, we have again simulate. So this is a Gmag RT. As I told you, we just load the XML. It will load automatically the RTT file. You can still modify the parameters of your motor if you want to change them. Sorry. But here we keep as by default, and we have simulated. And now, sorry, it is this one. You can see now the RTT result. Again, we have the 2000 RPM, the torque, which is quite a bit different than Psim and Gmag designer, but very same result. And here we can see again the current, which is a bit more more uh, without more ripple. Okay, it is smooth. Now we have seen that no matter if you simulate with Psim, Gmag Designer, or Gmag RT, the control is working well because you can see the same the speed, which is still reaching our reference, which is 2000 RPM. The current have a real good waveform, have a good shape, so we can conclude that my control is working well. But here it was just a design that we have done internally. Okay, we didn't use a motor control design suite. This is just our example that we have designed for this motor. Okay. So now, as a result, okay, I will show you the result comparison and just a quick conclusion. Okay, I want to show you now. If I open my, not this one, here, this is a comparison of the different speed of the three simulation that I showed you. The red one is by using the Psim linear model. The blue one is by using the real motor from Gmag Designer, and the green one is by using the RTT motor from Gmag RT. And as you can see, the shape is quite close, but if you prefer and if you want to get your real behavior, you need to use Gmag, as I told you, because here you have some ripple for Gmag, and this is a real behavior of your motor. And Gmag RT has the same shape with than Gmag Designer, but the shape, I mean, will be more linearized. Okay, then you can still have a very good accuracy. This is the main things. And now, if I show you again the current, I guess, yeah. Now you can see the different current for the phase A of your motor, for the Psim linear in red, the PMSM from Gmag Designer in blue as a co-simulation, and the PMSM from Gmag RT. So everything has been used into Psim. Okay, each motor has been simulated into Psim, and here you can see the result for the phase A, for example. And you can see again the result when I zoom directly. So the blue one is a linear one, I mean the Gmag one, the real one, okay? The green one is RTT behavior, and the red one is Psim. So as you can see, Psim is good because the shape is good, but if you prefer to get better accuracy for your motor, you need to use Gmag, of course. This is just a comparison between all the simulation we have done. And here, you can see directly the comparison time that we have done. So if you use only Psim and the linear model, it will take 16 seconds to simulate. If you use Gmag Designer in order to make the co-simulation, this simulation has last more than 1 day because Gmag Designer needs time to calculate and send back data and so on with Psim. So the total simulation was more than 1 day. Again, you can modify the total time of your simulation, of course. And now if you use the Gmag RT model, it is only 25 seconds. So as you can see, it is very fast, close to Psim. And if you want to use the best trade-off between Gmag Designer and Gmag RT, you can use Gmag RT because it will just give you a fast and accurate result. But now at the end, once you have done the linear simulation, the RT simulation, I think you want to get the real behavior at the end. So you will maybe still need to use Gmag Designer, but at least you have before compared Psim and Gmag RT, and you know that your control is working well with Gmag RT, so your control will still work with Gmag Designer. So at the end, you can confirm that everything is working well. Your power stage, your control stage, and your control of your motor. And your motor is also dealing good, is dealing well with Psim. So you can validate everything and you can make your prototype. But now, just before to end this meeting, maybe you are telling me, you are asking yourself, okay, he has presented me the motor control design suite, but he didn't do any simulation with the motor control design suite. So now my last simulation, okay, has been to use the motor control design suite in order to show you that it works. So here I have opened Psim again. I went into design suite And here, as you can see, you have the motor control gen suite. And you can open it for torque control, speed control, and so on. Okay, so you have the capability to use this template with Gmag. So now what I have done, I will just disable it. What I have done is I have again used my motor. So this motor, if you remember, I just go back to this slide. Maybe I will put are these parameters. So I take again my linear motor, okay, with RS, LD, LQ, and I paste this value inside these motors parameters for linear behavior, okay? And then I have decided to design my control strategy based on the specification of DJ gave me. The speed that he wants to get, the voltage input, the maximum current. So if it is one, but I decided to put two, but anyway, you can put at one. What is the switching frequency of my IGBTs? And I decided to use this kind of sampling frequency for the inner loop, for the outer loop, sorry. And then I decided to use this frequency for this value of crossover frequency. Okay, we have some rules to do that in Psim, so I applied this kind of rules, and I have, in fact, click on update parameters. Okay, and at the end, the main parameters to control my motor has been calculated automatically. So the gain of each PI block have been modified by calculating with this, by using this value directly. So you don't need to do anything else. Just modify these parameters again, click on update parameter file, and in fact, your control strategy will be modified. I didn't use the more complicated example with MPTV and so on, but I have done some example and it works. But in this example, I just wanted to use a field-oriented control strategy with basic stuff. Okay, so for that, this template has calculated for me the main parameters for doing the most complicated things in control loop, okay, to calculate my PI block. At the end, if you simulate, as you can see, it's very fast. It is reaching my 2000 RPM. So it's good. It's good. My simulation is working well. My control is okay. If I put my reference here, it's perfect. Okay. So now with DJ, we have taken the Gmag RT that DJ has created. So if you remember, it is the demonstration number 3. Okay, the same circuit with the Gmag RT. So I have taken this XML and RTT file. Okay, the same. So these parameters are not needed anymore. Okay, because they just help me to design my control. Now I used my RTT because this is I wanted to use my RT file. So basically, when you click on it, my coupler RT, my RT block, I just load this RTT that DJ gave me. I click on OK. I close it. No need to click on update parameter file because my control is already done. As you can see, it simulates quite fast. Again, I can see my reference, which is still at 2000. And now, if I modify the value and I want to get maybe 3000 RPM, I modify it. I click on update parameter file. Okay, due to the current. So this is why I have put 2500. Okay, it is due to my parameters. So you can modify it, increase the current, and you can get high speed. Okay, but anyway, I click on it. I click on update parameter file. I simulate, and I should obtain 2500 RPM. As you can see, it is working well. So you can use this kind of template in order to make the control loop for you. So we have shown you the 3 different simulations. First, the linear one. The second one was with Gmag Designer for co-simulation. The third one was with Gmag RT, okay, in order to get faster results, but keep the same accuracy. And now the last simulation was to use the motor control design suite in order to reuse the same motor that I used before. So now you don't need to create everything by your hand if you don't know which value you need to put for the PI, for this PI, for the current, for the speed, and so on. Just use our template. Fill in the motors parameters for the linear block. Check if your control is well done. If it is not well done, okay, you need to adapt. You need to adjust and tune your sampling frequency, your switching frequency, and so on. You need to tune that. And at the end, update them, simulate, and check. If it is work, perfect. You can disable your motor. You can enable your Gmag RT motor. And at the end, you will be able to simulate. But of course, you can check and you can use more advanced control algorithm, as you can see here, in order to get still high torque and high power in high speed region. You can use this kind of sub-circuit block, okay? And again, Psim will modify and calculate everything for you in order to fill in each parameters that each block needs to use, basically. The PI and the subcircuit needs to use some other stuff. And everything will be done. And at the end, this is not the same motor that I show you for this webinar, but again, here, as you can see, I want to get 6,000 RPM, and now I can see in real time the speed of my motor, which is increasing in order to reach my 6,000 RPM. So it means this motor could be any PMSM or it could be any motors from RT, okay, from Gmag RT. You can modify this and it will be any other motors. And as you can see now, it reached my 6,000 because my control has been well designed depending on your specification. So Psim just is the life for you. So if you have your motor design in Gmag, the second part is to use Psim in order to drive it. With this kind of process, you can drive any motors from Gmag. So I think we are out of time. I'm sorry for that. But at the end, this was the conclusion. Yeah, I would just, yeah, it was just the conclusion of this presentation. Use motor control design suite and Gmag, and it will design everything for you. DJ, do you have anything anything else to add?
No, I think everything is clear for me. So thank you.
Thank you, DJ.
Yeah.
So thank you, guys. I don't know if you have any question, if you have any feedback, anything.